Hello everyone, this video will serve as a refresher course for the topic of geometric sequence. So hopefully when you finish this video, you will be able to do some of the problems involving geometric sequence. So let's begin with a geometric sequence. And that is a sequence when you keep multiplying the same ratio to get the next number, so it's consistent. So the general formulas for an explicit rule for the geometric is a of n equals a of 1 times r to the n minus 1. And then the recursive rule, again, is you start with the first term that is given, and then you will have a of n equals previous term times the common difference of r. So r instead of d. D is for the common difference, and that is for arithmetic sequence, which is when you keep consistently adding the same number to get the next term. So geometric is going to be r for the ratio because you are multiplying by a number to get the next term. So let's take a look at the first example. First one I will do is number 1. Determine if the sequence is geometric. If it is, find the common ratio. So if you take a look at the list here, number 1, the ratio is multiplying the number going from one term to the next. So how do I go from -1 to 6? Well, that's multiplying by -6. And so if I try to follow the same pattern, 6 times -6 gives me a -36. And if I multiply by a -6 again, that will give me 216. And so this is very consistent. And so in fact, this is a geometric sequence. So yes, it is. And then what is the ratio? The ratio can be obtained by taking the second number dividing by the first number. So 6 divided by -1 will give us a -6. And you can also take -36 divided by 6. You will get the same ratio. So that is very consistent. So the ratio in this case is 6, -6. And that is the end of this problem. Number 7. Given the explicit formula for a geometric sequence, find the first 5 terms and the 8th term. So they want you to find the first 5 terms and then find the 8th term. So here's the first 5 terms. And then based on the formula, if we match it up with a of n equals 3 to the, r to the n minus 1, we can tell that the ratio in this case is actually 3. So r equals 3. So which means if we start with a of 1, that's going to be a of 1, which is 3 to the 1 minus 1. That's going to be 3 to the 0, which is 1. So we found out that a of 1 is actually 1. And a of 2 is going to be 3 to the 2 minus 1. That's going to be 3 to the 1 power. That's 3. And then a of 3 is 3 to the 3 minus 1. That's going to be 3 squared, which is 9. So that's the third term. So you can continue this pattern to find the rest of the terms, or you can just use the little shortcut that the previous number times the ratio is going to give you the next term. So that works for 1 times 3 is 3. 3 times 3 is 9. 9 times 3 will give us 27. And 27 times 3 will give us the fifth term of 81. So those are the first 5 terms in this sequence. And now we're going to find the 8th term because it's asking us to find the 8th term. So that will be 3 to the 8 minus 1. That will be 3 to the 7, which is 2187. So a of 8 is equal to 2187. And that's the end of that problem. Number 11 is the next one we're going to do. Given the recursive formula for a geometric sequence, find the common ratio and then the first 5 terms again and the explicit formula. And so we have, we're going to start with a of 1, which is 2 already. And it says find the first 5 terms. So we're going to continue the pattern and find the next 4 terms. And in this case, we can tell that the ratio, because the explicit formula says a of n is equal to a of n minus 1, which means the previous term times r. So we can tell that r, in this case, is actually equal to 2. So the common ratio is actually 2. And so if we actually follow this pattern by multiplying by 2, we will be able to obtain the next number. So 8 times 2 is 16. And then 16 times 2 will give us 32. So those are the first 5 terms in the sequence. And then we need to find the explicit formula. That's what the direction says. So that's using the formula a of n equals a1 times r to the n minus 1. So a of 1 in this case is actually given. That's 2. I mean, we found it already. That's 2. And it's actually given. So ratio is also 2, and then to the n minus 1. So there is the final equation for the explicit formula of this geometric sequence. And the next problem that I will be doing is 17. And so number 17 says, given the first term and the common ratio of geometric sequence, find the recursive formula and the 3 terms in the sequence after the last one given. So the last one given is a of 1. So if a of 1 is negative 4, we need to find 3 more terms after that. So let's make room for that. And then the ratio is 6. So we can just follow this by multiplying the sequence with the ratio. So negative 4 times 6 is negative 24. Times 6 is going to give us negative 144. And times 6 again will give us 864. And so those are the next 3 numbers in the sequence. And so let's go ahead and find the recursive formula. And that's what it says. So we are looking for the recursive formula. So recursive formula starts by expressing the first term, so a of 1. And then a of n is going to be a of n minus 1, which is the previous term, times the common ratio, which is 6. So this is the recursive formula. And given let's see if we answer the question completely. Given the first term, find the recursive formula and the 3 terms. So we are done with the problem. That is the recursive method, and that's the next 3 terms in the sequence. And that's the end of the problem. Next, we're going to take a look at number 21. Given a term in a geometric sequence and the common ratio, find the first 5 terms and the explicit formula and recursive formula. So we need both formulas, but we're going to start with the first 5 terms. Okay, so we are actually given one of the terms. So here's the first 5 terms. And we're given the 4th term. So that's 1, 2, 3, 4. That's right here. And we now can go ahead and trace the rest of the 5 terms. So the ratio is negative 5, which means you are multiplying by negative 5 to get to the next term always. So we can use this to kind of like just trace backwards. What number times negative 5 gives me a 25? So that has to be a negative 5, because negative times negative is positive. So we're going to go backwards again. What number times negative 5 gives me negative 5? That's a 1. And then the last one will be here. 25 times negative 25 is negative 125. The tricky one is going to be the one that's less than the 1. So what number times negative 5 gives you 1? So the easier way actually is to take 1 divided by negative 5. And so I already have the answer right away. It's negative 1/5. So if you take negative 1/5 and times negative 5, you will have 1 as the answer. So that is the complete list for the first 5 terms. Next, we're going to find the explicit formula. The explicit is a of n equals a1 times r to the n minus 1. And so we are going to substitute a of 1 that we just found. This is a of 1 right here. So it's negative 1/5. Ratio is negative 5. And then to the n minus 1. So that's our explicit formula. And then the recursive formula is going to start by stating that a of 1 equals negative 1/5. That's the first term. And then a of n is going to be previous term, a of n minus 1, times the ratio, which is negative 5. So that's the both formulas, explicit and recursive formula for the list of sequence that is given. And that's the end of problem. Number 23 is the last problem we're going to do. Given two terms in a geometric sequence, find the 8th term and the recursive formula. So we need to go through and find the complete list first by using the two terms. So we're going to start by finding the explicit rule first and then use that to obtain our recursive. So we will use the fact that a of n is equal to a1 times r to the n minus 1. So this is our explicit formula. So we're going to use that and make use of the information. So we have a of 4 that is given. We do not know a1, so we're going to leave that in the formula. And we do not know the ratio either, so that's an unknown. And we do know that this is the nth term. So we have the formula. I'm going to substitute our given that the 4th term is negative 12, so enter that. We do not know a1 or r. We're going to keep those, and that's a 3rd power here. And the next equation, same thing, we're going to do a of 5th is equal to a of 1 times r to the 5 minus 1. And the given is negative 6. That's going to be a1 r to the 4th power. Next, I'm going to use one of the equations and solve for a1. So I'm going to divide by r cubed on both sides. And that will give me a1 equals negative 12 over r cubed. And we're going to use this to substitute into the second equation for a1. So we know a1 is equal to negative 12 over r cubed. So we're going to substitute that into the second equation. So that's a1. And then we have r to the 4th. That's part of this equation. Notice that the r cubed here can cancel out 3 of the r, so we got r left. So we got negative 6 equals negative 12r. So again, this is a 4 minus 3, which is 1 left. Okay, so we subtract. So we have 1r left, and that goes on top to multiply with the 12. And to get r by itself, I divide it by negative 12, and I'll have r equals 1/2. So the ratio is actually 1/2. Next, I'm going to substitute that back in here into r. So it is negative 12 times 1/2 to the 3rd power. That's negative 12 over 1 over 8. And that's going to be negative 12 dividing by 1. 8 is like multiplying by 8. So that should give me a negative 96. So I have found a1, the first term in the sequence, is actually negative 96. And the ratio is r. So isn't that wonderful? We already found a1 and r. So now with that, we can recreate whatever formula we want to recreate. So we can actually state the recursive rule. So a of 1 is equal to 96. That's our starting point. And then a of n is the previous term. That's a of n minus 1 times the ratio, which is 1/2. And this is the formula for the recursive rule. And the last thing that we're going to do to address the problem is it's asking us to find a's of 8. So a of 8 is going to be, we're going to actually use, of course, you can use the recursive and keep going with the list, or you can use the explicit rule, which is a's of n equals negative 96 times the ratio of 1/2 to the n minus 1. So using that formula, we're going to substitute 8. And that is 1/2 to the 8 minus 1, which is 7. And if you simplify that, that would be negative 96 times 1 over 128. Simplifying it, you should have the fraction of negative 3 over 4 as the answer for the 8th term. And that is the end of the problem. And so now you may go ahead and finish this worksheet, and you may go back to the video again to whichever problem you need more help, and just keep watching it and have fun. Good luck and take care.